Okay, so let's now move on to day 2. And we're going to focus on evaluating. So on day 1, we went over again determining quadrants, identifying reference angles, and that's extremely important to then evaluate. So evaluating all comes back to this chart. So at any point, if I were to ask you, what's the cosine of 45 degrees? You have to be able to recall from memory that it's square root of 2 over 2. Now, if you have to write this at the top of your paper, that's totally fine. The 0 and 90, I don't really like to write charts for that. I like to think of it more in terms of the unit circle. But let me remind you that 30, 45, and 60 degrees, these are our reference angles. All your answers come back to your reference angles or one of your points on the axes of the unit circle. So now let's use it. I said when you completed the form that I would come back to this. So all of this work should be completed already, and it's going to make our job today that much easier. So question number 10, sine of 45 degrees. That's a first quadrant angle. It's already its reference angle. So what's the sine of 45 degrees? I go back to my chart. The sine of 45 degrees is square root of 2 over 2. And I'll take that off. So, spoiler alert here. Every single answer here is going to be square root of 2 over 2. Why? Because every single value in parts A through D have a reference angle of 45 degrees. Because I'm finding the sine of 45 degrees, the sine of 45 degrees never changes from square root of 2 over 2. What do we need to take into consideration? We need to take into consideration the quadrants, because only the first and second quadrants sine values are positive. So now, hopefully you're seeing the significance of the opposite. So the sine of 225 degrees is negative square root of 2 over 2. Why? Because that's a third quadrant angle, and in the third quadrant, my y-coordinate, my sine value is negative. Likewise, for the fourth quadrant, the sine of 315 degrees is negative square root of 2 over 2, because in the fourth quadrant, only the cosine value is positive, so it makes the sine value negative. So that's why on the form you had to complete, wrong option, you needed to have those negatives in there. All right, let's look at number 11. So number 11, check out the reference angles. All the reference angles are 60 degrees. So when I go to my chart, okay, what's the cosine of 60 degrees? The cosine of 60 degrees is a half. Great. So I know all my exact values will be a half. We just have to determine which ones are positive and negative. Where does that information come from? That's the significance of the quadrant. So in the first and fourth quadrant, the cosine has a positive value. So that means when I answer an angle in the second and third, the cosine value better be negative. Okay, so that's why we had you first be really good with reference angles and quadrants so that this just becomes a natural consequence. All right, so now we're changing a little bit. All right, the first two had the same reference angle in all four quadrants. Okay, sine of 30 degrees, that is a first quadrant angle. So sine of 30 is 1/2. Negative 30 degrees, remember negative angle measures from start, we rotate in a clockwise direction now. So that lands me in quadrant 4. In the fourth quadrant, my sine value is negative. Okay. Why doesn't this one work? So the sine of negative 30 degrees would be negative half. All right, now cosine of 30, that's in the first quadrant. That is one of my reference angles. So this is, I don't know why this isn't working. Square root of 3 over 2. Negative 30 degrees is in the fourth quadrant. In the fourth quadrant, the cosine is positive, so this takes on the same value. All right, number 13. So now I'm dealing with sine and cosine in parts A and B in the fourth quadrant. Cosine is positive while the sine is negative. So what's my reference angle? The sine of 30 degrees is a half. I don't know. I'm sorry, guys. But it's got to be the opposite because in the fourth quadrant, sine is negative. In the fourth quadrant, though, cosine is positive. So cosine of 30 degrees is the square root of 3 over 2. And if you're sitting here like, where is she getting these values? The values all come back to what we proved in the right triangles yesterday and from this convenient little chart. The cosine of 30 degrees is square root of 3 over 2. All right, now radians. I prefer radians for doing these because your reference angle always just comes from the denominator. The work is determining the quadrant, okay? And recall in radians, 0, 1/2 pi, 1 pi, 3/2 pi, and then 2 pi. Okay, so what's the significance of that? My top number, my numerator, is my bottom number minus 1 because I want that fraction to be smaller than 1. In the third quadrant, my top number is my bottom number plus 1 because I want it to be a little bit bigger than 1 pi. In the fourth quadrant, my top number is twice my bottom number minus 1. Remember, if I were to double my bottom number, I would be at 2 pi, but I have to be less than 2 pi. That's why I subtract the 1. Okay, so both C and D, 7 pi over 6, are third quadrant angles. In the third quadrant, both sine and cosine are negative. Pi over 6 is equal to 30 degrees. So this is actually the same answer as A. And then D would be negative square root of 3 over 2. 30 degrees is equal to pi over 6 radians. So you do have to be able to know which radian measure goes with which degree measure in radians. Okay, so here we are in radians again. Pi over 4, that is one of my first quadrant angles. Cosine of pi over 4 is square root of 2 over 2. Negative pi over 3 as a rotation puts me in the fourth quadrant. In the fourth quadrant, sine is negative. Pi over 3 is the same as 60 degrees. The sine of pi over 3 is square root of 3 over 2. It's negative because of its quadrant. Cosine of 5 pi over 6. 5 pi over 6 is a second quadrant angle. Its reference angle would be the opposite of the cosine of pi over 6. So that's also negative square root of 3 over 2. Negative root 3 over 2. And then lastly, sine of negative 300 degrees. If I start here and I rotate 300 degrees in the clockwise direction, it would land me in quadrant 1. In quadrant 1, everything is positive. Where did the 60 come from? Well, I took my angle and I added 360 to it, because adding 360 to it would make it positive. Now that it's positive, 60 degrees is just my first quadrant angle. Sine of 60 degrees, that's positive root 3 over 2. All right, so your classwork, homework, I created a form. You're going to do numbers 11 through 18, all of them, and you will follow the directions. It's find the exact value of the sine and cosine. So what that means is this is what your answer will look like on numbers 11 through 18. Okay, that doesn't want to work. The exact value column. determining the quadrant and the reference angles are the means for you to get there. Okay, but your final answer when you enter it in the form, it's going to be one of the values from the chart that we started with. Or I'm going to do a couple examples. I have a few more minutes. I'm going to do a couple examples of determining exact values on the unit circle, because I'm sure that's on there. Okay, so if I asked you, what's the sine of pi over 2? Okay, well, pi over 2 doesn't have a quadrant or a reference angle. Pi over 2 is up at 90 degrees on the unit circle. So if one of your angles is on one of the coordinate axes, we refer back to its ordered pair. So up here, 0, 1. I cannot stress enough. Your x-coordinate gives you your cosine of your angle measure. Your y-coordinate gives you your sine of your angle measure. So if you were to find the exact value for the sine of pi over 2, that's the y-coordinate up at pi over 2. So the sine of pi over 2 would be 1. If I asked you for the cosine of negative pi, okay, well, I start here. If I were to rotate in the clockwise direction, pi radians, it would put me at positive pi. My ordered pair over there is negative 1, 0. So the cosine is the x-coordinate of that point. So the exact value for the cosine of negative pi would be negative 1. Sine of negative 270 degrees. Okay, so from start, I rotate negative 270 degrees. Negative 90, negative 180, negative 270. So this is at the same spot as 90 degrees. Sine is my y-coordinate. Up at pi over 2, we already answered this one. The sine of 90 degrees would be positive 1. All right, how about the cosine of 3 pi over 2? 3 pi over 2, no quadrant, no reference angle. I'm down here on my unit circle. Ordered pair is 0, negative 1. Cosine is the x-coordinate, so the x-coordinate 3 pi over 2 is 0. Okay, so I think you have an understanding of how to determine them now. If they're on one of the coordinate axes, no quadrant, no reference angle, we go right to the point and we either determine the x or the y coordinate. Okay, so again, complete the form. There is quite a bit of them. There's parts A through D for each problem, but you just have to practice. Have a good day.